Okay, Coyotes, so in upper elementary, we're going to continue with cube root. So I have a number for you, and this number is 79,507. This is a very large number. We know that if I want to find the cube root of a number, I have to build the largest cube possible. So do we have enough material to do this problem? No, we can't use the 2 centimeter by 2 centimeter cubes, and we can't use the unit cubes, and we can't use the chart because it doesn't go as big as this number. So we are going to have to use the decimal orders to solve this problem. We have to remember when we have a unit or single digit and we cube it, the largest number it can be is 3 digits. So let's place our tick mark here, 1, 2, 3. So we know in our answer, we're gonna have tens and units. So this tick mark represents that these 3 digits is what I'm going to look for in this period, because I know I can have a 1-digit cube root. But if I go one more, I can have a 2-digit cube root. And if I take a unit and multiply it by itself 3 times, I get hundreds. Tens times tens times tens will give me thousands. The next one would be hundreds times hundreds times hundreds would equal millions. So we need to make the cube of the first 2 digits. We are going to look at the leftmost period to find the cube root of 79. Well, we can use the chart for this. So if you look back to your n cubed and n squared chart, you can see that the closest number to the closest cube root to 79 is 4 cubed. So for that, I know I can use this cube. So let's take away, what is 4 cubed? Well, it's 64. So let's take that away from 79. And I'm left with 15. So we know 4 is in our answer because we have 4 cubed. So I'm going to write to the side how I got that number, where 64 came from. So 64 came from 4 cubed. Well, let's see. I have 15 thousands and I need to bring down the 5. So I'm going to go ahead and bring down the 5. Well, one thing I need to ask myself is, how can I extend this cube? I want to extend the cube in 3 different directions. So I would need to use squares of 4. So I know that I would need to extend it 1 layer here, 1 layer here, and 1 layer here. So that's 3 squares of 4. Well, we need to record how much we used. So here, we're gonna say we used 4 squared times how many? 3, which equals, so remember 4 squared is 16, and 16 times 3 is 48. So we can take away 48 from this number, and we get 7, 1, 0, and 1. So 107. Well, I also need to fill in I have to keep working. So now I need to think, how can I fill in hold on. Okay, so I need to multiply 4 squared times 1. I'm just going to rewrite this to the side. So for where I got 48 was 4 squared times 1 times 3. So now I took away, now I have to keep extending. So now I had another 48. So I have to subtract that. And I get 69, and I need to extend it one more layer. And then I have to subtract again. And I get 11, bring down the 0, and now I'm at 110. Well, now I've subtracted 48 3 times because I have 3 squares on each side. So if we were to multiply 4 squared times 9, we would get 48 plus 48 plus 48. Okay, now we need to think, okay, well, what do I need to fill in this space here? I need to extend it, but I don't think 4 is going to work because let's count how much we have. 1, 2, 3. Huh. I think we need to use the square of 3. So let's take a look. If we add 4 to each side, we're able to fill out the square even more. So we have to record what we are going to take away. Well, we're taking, this line, 3 squared times 4 times 3, which is 108. So 108 leaves us with 27. So now we can use our end chart again and go back. The cube of 3 is 27. So we get our answer. Here we used 3 cubed equals 27. So the cube root of 79,507 is 43. So for follow-up, I would like for you to try this. Okay, so let's try these two for follow-up, and we'll go from there. So that's all I have. Bye, coyotes.